Hey everyone, this week we are going to be dividing decimals. Last week we multiplied decimals, so we're moving on to division. And as with multiplication, we have three different ways to solve. We have the area model, we have the partial product, and then we have the standard algorithm. There are also three different ways to kind of explain this problem and work out this problem, or these types of problems. And so if we go ahead and look at number one, it says 2 divided by 2/10. So if we start, I'm going to divide my paper up, or my area to work, in 3 sections. And I will title the first section Inverse Operation, because we know what that means, okay? And I will title the second section Division. Okay, we can underline those if we want. And then my final area down here will be called Base 10. And we know what base 10 is, right? The base 10 blocks the green squares and cubes and 10 sticks or 10th sticks, right? So let's look at inverse operation first. So with the inverse operation of division is multiplication, right? Because they undo each other. If I have 7 times 3 equals 21, then 21 divided by 3 brings me back to 7, right? They are inverse operations. They undo each other. So with that knowledge, we know that we can do, instead of 2 divided by 2/10, we can do 2/10 times something gives me 2, right? Because it's the inverse operation. So as we think about this, we're thinking, how many groups of 2/10 can we have to give us 2 wholes, right? And so what can we multiply 2/10 by to get 2 wholes? So let's take a break and let's look at the base 10 of this. If I have 2 wholes, okay, how many tenths are in 1 whole? 10, right? So that means that we would have 2, 2, 2, and 2, right? We would have 2/10, 2/10, 2/10, 2/10, 2/10. Okay, so then if I have 2 wholes instead of just 1, I have to break this up into 2/10 as well, correct? So now, how many groups of 2/10 do we have to make 2 wholes? Well, we have 1, 2, 3, 4, 5 here, and then we have 6, 7, 8, 9, 10. So we have 10 groups of 2/10, and that equals 2 wholes. Does that make sense? So we took 2 wholes and divided it up into 2/10, right? And if you actually had a real base 10, like a 100th grid, you would be able to shade in these tenths, right? You would be able to shade in 2/10 and 2/10 and 2/10, and it would be a little bit more clear than my drawing here. I understand it's not the best, but it's okay. I know that there are 5 groups of 2/10 in 1 whole, right? So if there's 5 groups of 2/10 in 1 whole, then there must be 10 groups of 2/10 in 2 wholes, right? And so really, I would multiply this by 10. Another way to look at the inverse operation, instead of looking at the base 10 blocks, right? I know that if I'm moving from 2/10 and I'm trying to get to 2, right? There's a very easy little motion here, right? You move that decimal to the right one place, because we know when we move the decimal to the right one place, we know that we are multiplying by 10, correct? So that helps us know that 2/10 times 10 would give us 2, right? And so that's a quick little trick that you can use. And then finally, division, the division way to solve this problem. We would set this up like any normal division problem, right? We would have 2/10 on the outside and 2 as a whole number on the inside. That way this reads 2 divided by 2/10, okay? Once we set up our problem, we can look at this and say, okay, let's make this number on the left, let's make that a whole number, right? How can we make 2/10 a whole number? Well, we can move the decimal one place to the right, right? That would bring that to a 2. And whatever you do to the outside, you must do the same to the number on the inside, right? So if our decimal is here for a whole number 2, we know that we can scoot that decimal one place to the right, and that would give us what? 20, right? So now we have 20 divided by 2 instead of 2 divided by 2/10. So now this is a little bit easier on us, isn't it? And since we do the same thing to both numbers on the outside and the inside, our answer can just stay 10, and we don't have to move any decimals back to where they need to be. As long as you do the same to the inside as you did the outside, your answer will stay whatever it is, right? Because the value doesn't change. Whatever 20 divided by 2 is going to be the same as 2 divided by 2/10. The value is the same. So there are 10 groups of 2 in 20, so there must be 10 groups of 2/10 in the number 2, in a whole number 2. So our final answer for this, as you can tell, I'll circle it in blue, would be 10, right? Okay, so now that we've kind of explored the 3 different ways, let's try one more. Let's try the problem of 99 hundredths divided by 11. So again, I'm going to split up my working area into 3 pieces. Now, we're not going to do this for every problem, right? You're not going to work out this particular problem in 3 different ways every time, right? On your test, you're not going to do all 3 ways. You may need to show all 3 ways throughout the test, but for every problem, you may solve it a different way. Okay, so you don't have to use all of these every single time. But first, let's start with the inverse operation of multiplication, right? And then we're going to have the division way. And then we have the base 10. Okay, so let's look at the inverse operation first. If I know that if my problem or my equation is 99 hundredths divided by 11, I know that I can change this around to be 11 times something gives me 99 hundredths, right? So that would be my inverse operation of the equation that I was given in the beginning. And if we take a minute to remember the rule whenever we're multiplying decimals, my answer should show how many decimal places are between my 2 factors, right? And remember, the factors are what we are multiplying together. So if I have 11 times something, those would be my 2 factors, and my product would be 99 hundredths. So if 11 has no decimal places like to the right of it, right, since it's a whole number, then our other factor must have 2 decimal places behind there, right? So it must be, in other words, in the hundredths, right? And we know we can look at this and say, okay, well, 11 times 9 is 99 hundredths. But if I'm trying to change this into hundredths, it's not just 11 times 9, right? Because that would be 99. But we need 11 times what? 9 hundredths to make that match our product, right? And so now that we've done 11 times 9 hundredths, that could give us 99 hundredths. So our answer, our final answer, would be 9 hundredths. Okay, now let's look at the other 2 ways very quickly. We have division. Okay, we can go ahead and look at the division way. Let me switch to red. Let's see. So we have 11 on the outside, and we would have 99 hundredths on the inside, right? Now, remember earlier in problem number 1, we moved the decimal, right? We moved the decimal on the outside first and then the inside. Now, we only want to focus on the outside number first because that's the only number that really has to be a whole number, okay? So whenever we're doing this, we can look at this and say, okay, well, 11 is a whole number already, right? So are we going to move any decimal here? No, we are not going to move any decimal. So what we do, instead of moving a decimal, wherever the decimal place is in this, I'm actually going to do a blue. Wherever the decimal place is, that's where the decimal will stay. So if the outer number, right, the 11 on the outside of the bracket, is a whole number already, then we leave everything the same. We just carry that decimal up into our quotient and keep it in the same position. Now we can view this problem. Since we already know where our decimal place is going to be, we can view this problem as 99 divided by 11, when really the problem is 99 hundredths divided by 11. We already have our decimal place where it needs to be, right? So we can think for just a moment, 99 divided by 11. What is that? It would be 9, right? And then we have to fill in all of the other zeros that we need. Again, our final answer, our final quotient would be 9 hundredths. And so finally, we would have the base 10 model. And with the base 10 model, it would be a lot harder to sit here and draw, right? But we would shade in 99 hundredths. We would shade in 99 hundredths, whatever that would look like. We would leave one little hundredth out right there at the bottom, right? And then we would shade in all of the 99 hundredths. And once we had that all shaded in, then we would take 11 groups out. So this really, in this problem, this would be more of a test, like a check your answer type of thing, right? And so we would check it by sectioning off. Okay, here's 9 hundredths, and then another 9 hundredths. We would section off, and then another 9 hundredths, and it looks complicated, but we would section off 9 hundredths, and we would eventually find that there are 11 groups of 9 hundredths. So that would be to check our answer. We would find 11 groups of 9 hundredths, and that would give us 99 hundredths as a total, right? So our final answer would be found here. Okay, so there's the 3 ways, right? And really, the base 10 is almost as a kind of prove your answer or check your answer type of method. But if you want to use the inverse operation, that's fantastic. Sometimes it may be easier to use the inverse. Sometimes it may be easier to use division. And that's your call. You can choose to do some with the inverse operation or some with the division operation. And again, that is your decision. And sometimes some problems may be easier to use the inverse with multiplication. Some may be easier to use division. And so you have to make the call on that. And for the dojo point this week, I'm going to go ahead and show you the superhero. And the superhero for this week is Wolverine. So if you write down on a sheet of paper his name, Wolverine, and then write your name on the paper, your teacher will give you a dojo point for watching this video because you guys are trying really hard to get better at math and you're rocking it. Okay, and I'm very proud of you guys. So always give it your best, never give up. Ask your teacher for help if you need, if you have any questions, if you need some help on these problems, please ask us. We will help you, and we will be working on this throughout the week. I hope you guys have an awesome week and keep up the good work.